Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So this is the second part of our module this week, which is the LTI system. Okay, do you guys hear me? Sound check. Okay.
Yes, brother.
Right. Okay, so today we have seen the first part, which is when we have an LTI system. So we can represent it based on two things. So either it is a difference equation or impulse response. So we already know what is a difference equation. Difference equation is just the equation of the system, because a system is something which is in one equation. You have input, you have output, and you have operation. Right, so that operation can be on input sequence or on the output sequence. And we have seen how to, if we have only input sequence, so we already seen how to convert this difference equation into impulse response. Okay, so we have seen that. And we already have seen a type of the impulse response, so which is the FIR and IIR. Okay, I think I can show you some, I have a slide here. So let's see, so we do some, a little bit a recap. So what is the LTI system? So LTI system is, we can represent it using a difference equation. So what is a difference equation? System representation based on its process. Okay, so that's how we can see that what are the input sequence, what are output sequence involved, which one's supposed to be sum, which one's supposed to be multiplied with some weights. So what are the delay involved? So we see the process. So we see the process. So that is what we call a difference equation. And LTI system is represented by difference equation restricted to operation. We already know that we have only three operations. So one is the delay. So this is an example of delay. So this is no delay. So this is a delay by one sample. Output, which is delay by one sample. This is output, delay by two samples. Okay, the same thing, this is input. When it is an XN, this is input. And this is examples of delaying the input signal. Okay, so one is delay, and then there is a summation. So we need to sum. So there is a summation to the output signal. We do sum everything, and then we sum all the sequence. The other one is weight multiplication. So we have seen this. So if it is a multiply to the output sequence, so that one is a weight. So this is also a weight. So there's a difference. So one is the weight to the input sequence. Another one is the weight to the output sequence. And the weights are actually later, we will call it a filter. So this is actually the filter itself. So just now, we can see that from the equation that we have seen in the previous slides from the previous hour. So we can say that we see this A, okay, A variable. So actually, this is what we call a coefficient A. So whatever the weight for the output sequence, we can put it this way. So we call it coefficient A. And the other one is coefficient B. Right? So we have seen this, the A and B variable. So this is 2, 3, and 2. Put it into a vector. So we call it coefficient B. And we can convert this into impulse response. So what is the impulse response? Impulse response is another representation of LTI system. So this is a system representation based on its filter. So because actually later, this is what we call the filter. So when you say that filter, what is a filter? Filter is just a sequence of values. So that is actually a filter. Digital filter is actually just a sequence of value, combination of a coefficient A and coefficient B. So that is a filter. If you have a low pass filter, so you will ask, so what is the coefficient A? What is the coefficient B for that filter? Right? Later, at the end of the semester, maybe I think the last 3 weeks, so we will learn on how to come up with this value. When you want to have a low pass filter or high pass filter, so what will be this value? So we will design this value actually. right? So that's the filter. And for example, if we have this is a FIR. So what is a FIR? There is no output sequence. There is no output sequence. And by definition, finite impulse response is where your impulse response, the length is finite. So this is where if, for example, we have a yn equals to 2xn plus 3xn minus 1 plus 2xn minus 2. So what is the hn? Hn is actually equals to b. So what is the b? The b is just taking those the 2, 3, and 2 value. 2, 3, 2. So that is the hn. So for FIR, what is the FIR? When you see no output sequence. So what you have is only a current output. So then what is the FIR? Very simple, straightforward. Just take that weight. So that will be your hn, the impulse response. So this is for FIR. The other one, which is the IIR. So because the IIR will have output sequence, okay? IIR will have an output sequence. So you will have two coefficient B and coefficient A. So we need to convert these two because we have now two, and then we need to convert into a sequence, which is Hn. So one vector, two vector. So this two vector, you need to convert it into one vector, which is called Hn. And that one is not straightforward. We need to use Z transform to do that. Okay, from Hn into A and B, or from A and B to Hn. So we need to use Z transform to do that. So which is not this week topic. Okay, that will be a next week topic. So that's why this week we just look at FIR system alone, which is this one, the FIR. Right? So we'll look at next week. Okay, next, actually we will look into this one, convolution. I just want to show this again. For FIR, okay, please look into this equation carefully. So you need to remember this equation. Okay, so what is it? So this is a summation of that bk multiply with xn minus k. So what is the bk again? So bk is the coefficient b, the coefficient b. So this is a weight for input sequence, weight for input sequence. And because our bk is finite, why? Because this is finite impulse response. So it will start from somewhere, n, some value, until some value, which is n. And from n to m, so it is a finite length. Okay, so let's go to this one is actually also important, but I'm going to skip this one for today. For today, I'm going to skip this one. Later, maybe week 4 or 5. So we will get back to this one. Okay, I'm skipping it now, but later we will get back into that. So our next topic is what we call a convolution. So what is a convolution? So the mathematical operation of which some of the input sequence shown so far in the FIR system. So actually a mathematical operation called convolution. This one, okay? This equation again. Let's get back to the FIR equation, the general equation of FIR. So actually this is convolution. This is a convolution. So what is a convolution? Convolution is actually when you have a LTI system. When you have LTI system, the operation of LTI system is called convolution. Okay, that is actually convolution. So because this is a very unique and special system, the linear and time invariant system, even the process itself, there is a name for it. So the process is called, the process of this delay, multiply, and then sum. Okay, the combination of these three, delay, multiply with weights, and then sum everything. So that one is actually called convolution. Okay, so special. Even that process has a name, so which is a convolution. And again, convolution is not new to you guys because you have seen convolution in several courses before. Okay, so that's why I give you one video. Okay, one video from YouTube from your previous course. So how to do convolution, and that one is I give you two videos on convolution. One is on a discrete, a continuous time convolution. The second one is on discrete time convolution. Okay. So what do you think? Have you seen? Because from e-learning I checked this morning, as I mentioned in the WhatsApp. So I'm not sure now. At that time, less than half watched the video. So how about now? Have you watched those two? Those who have watched, what do you think? What is the difference between the continuous time convolution and the discrete time convolution? What can you say about those process? Anyone? Can you respond? So what do you think? So hopefully those already watched can respond. Those who haven't watched, so maybe you will have some difficulty today. Anyone? Can you give some response? So what do you think about those two process? One is a convolution. Let's see. Let's see. So now it's 12:22. So actually we have this convolution, right? So it is on a step signal, and then this one. The title is a convolution, discrete time convolution shortcut methods. So what do you think? So which one is easier?
Discrete, for sure.
For sure, discrete is easier, right? So that's why DSP, you should get A. At least A minus.
Yeah.
So most of you should get A plus. Okay, so because if you look at even the convolution, so how difficult it is to do a continuous time convolution. So because it's using integration. It's using integration. And this one, it is as simple as using some you can say that maybe you can have a table here. Even I don't have to teach you, you already know how to do it. Okay, I'm just going to explain what is the concept behind it. So actually computing it is very straightforward, So, okay, let's see. We will look at several examples. Actually, this is, please watch the following video before our Tuesday class and spot one mistake from the video. Okay, just spot that one. If we have time, we will get back to that one. If not, we're not going to discuss the mistake. So, but hopefully you can spot the mistake. Okay. All right, so this is a convolution. If you look at these slides, so we have a lot of things. There are 4 operations in convolution. There's a summation, weight multiplication, delay, folding, and then a lot of step 1 up to 6. Okay, actually, this is a very detailed steps. It doesn't have to follow this. Okay, so that's why I'm giving you this the shortcut method. Okay, and you can use this shortcut method, no problem. Okay, in test exam or whatever assignment that you have, you can use that. It doesn't need to follow this 6 step because this is actually a very detailed step on how the convolution is done. So I think it doesn't have to do that anymore. Okay, let's see example. Find Yn. What is a convolution again? Because we need to be very, very clear on what is a convolution. We learn convolution. Even actually, you already learn convolution from a maths course. I think there's engineering maths. Not sure engineering maths 1 or engineering maths 2. So you already learn convolution at that time. Not even an electrical courses. And then signal system, you do convolution. And then there is, again, that control course, you do a convolution also. Everything is continuous convolution. So today we're going to look at, so that's why you need to know what is actually convolution. So again, convolution is actually the process in the LTI system. Okay, if it's not LTI system, we're not calling it convolution. That's another process. Okay, so if it is LTI system, because a system must consist input, output, and a process. Okay, that process is called convolution. Okay, let's do this simple example. Find Yn, the output of a system, where the input signal Xn and its impulse response are as follows. Okay, so we have Xn, so we have impulse response. So now this is impulse response. So what is the impulse response? And impulse response is representing a system. So this is where we can do this. So we have Xn, and then we have output Yn. So this is your Hn. And this is the Xn, Hn in the middle. So we need to find this one, Yn. Okay, we need to find this one. And for convolution, we have even a symbol because it's a very special operation. So there is a name, there is a symbol, even there is a symbol for it. Xn star. So that star is convolution. It's a symbol for convolution. Means this one. So let's see the equation again. Okay, this whole equation. So you have xk, and then you multiply with hn minus k. So this whole equation can be simplified into this one. Okay, a very special process. And actually, it doesn't come from engineering, so it comes from maths. So maths invented it first, and then we use it in engineering. So it doesn't come from electrical engineering. It comes from mathematical terms. Okay, so when you see this, that star, so means that what is this? So this is actually a convolution between Xn and Hn. But in terms of when we learn electrical electronic engineering, so this is actually a system. So we can call this a system. So that system is actually, we have input Xn, so which this Xn will be processed by our impulse response system and get output signal. Okay. So let's do that a simple example here. So we will do the shortcut method. Okay. We need to find this one, Yn. We will do the shortcut method because sometimes shortcut is very good. So this is okay. Index 0 is here, means that that index 0 is 0. And then this is this one. The index 0 is here. If you want to put it into a sequence of a value, so we can put it as a xn equals to 0, 1, 2, 3. Okay, or optionally, you can put a underline. If not, we already know that it starts with the index 0 here. This one is equals to 1, 1, 2, 2. And where is the index 0? The index 0 is at this value, which is this one. Okay, that underline is actually indicating index 0. So n equals to 0. Then we will know that this is index n equals to -1, this is -2, and then this is 1. And this one, we know that this is index 0, so this is 1, 2, and 3. Okay, so let's find Yn. So what we have is n. So where does it start? So it starts from the lowest n. What we have here is a -2. Okay, so maybe we can start with -2. So -2, and then we have -1, 0, 1, 2. Okay, if you want to proceed, then you can put 3, 4, 5, 6 until whatever sufficient. And then xn, so what is xn? Xn is 0, 1, 2, 3. So you have 0 here, 1, 2, and 3. Okay, I think we need more. You'll see it later. Hn is 1, 1, 2, 2, 1, 1, 2, 2, but it starts from here, 1, 1, 2, 2. Okay, so this is what we have. So we have n, so those n, and then we have xn, starting at index 0, and then 1, 2, 3. So this is just, it happened that it is the same with the index. Okay, so it's possible. And then hn, it starts with the index -2. So we have a 1, 1, 2, 2. So this is where next we will do a multiplication. We will do a multiplication. So what we do here is actually we are putting a delay. So this is a delay. So we put it on the same index, those kind of thing. Okay. Now we will do a multiplication. Because what is the process of LTI system again? So we have 3 things only. One is a delay, and then multiply with a weight, and then summation. Okay, so when you put it on index such this, so we can say that this is, we already finished on the first one, which is the delay operation. So next we will do a multiplication. So we will multiply one by one. So this is let's say 0, 1, 2, 3. So you will multiply with the first one. Okay, 0 and 1, 0, and then 1 to 1, 1, 2, 3. Okay, we start from here. Second one, so we will start from here. So same thing, everything multiply by 1. So 0, 1, 2, 3. And then the third one, now you need to multiply by 2. 0, 2, 4, 6. Again, we need to multiply by 2. 0, 2, 4, 6. So the last one is to do the summation. Okay, you will do the summation to get yn. So this is a 0. 1 plus 0 is 1. 2 plus 1 is 3. 3, 5, 7. 3, 7, 9. 10. And 6. Okay, where is the index 0? So it is here. Okay, always, that one is always the index 0. So this is your yn. Okay, if you want to simplify it, doesn't need to write this 0. Okay, it doesn't need to write this 0. So it can be just 1, 3, 7, 9, 10, 6. Okay. So let's do another one now. You guys do it. Okay, next example. So I want you to do it. So let's say xn. I give you a very simple 1, 1, 1, 1, and then the hn is let's say 0.5, 0.5. Okay, so let's do this. So this is a very very simple value. So try to do it. I give you 2 minutes. So actually you can complete it within 1 minute. So I give you 2 minutes, and then let's see. So what will be the answer? So you can write answer on the chat section. Okay, please try it using the shortcut method. So if you cannot remember, so this is how we do it. Any question you can ask if you don't understand any part of it.
Doctor, may I see the question again? Sorry.
Oh, okay, sorry. So the question is this one. 1111 HN is 0.5, 0.5.
That's it.
So whoever already sleeping, so this is the time to wake up. Okay, one more minute. One more minute. If you're already used to it, it's supposed to be less than 1 minute. If you have the answer already, so you can type it on the chat section. Okay, I hope hopefully you already got the answer. Please, someone write your answer. At least we can see one answer. 0.5, 1, 1, 1, 0.5. Okay, thank you, Omar. So let's do this together. 0.5, okay, same answer. Okay, so yeah, so maybe that's the correct answer. Okay, let's do that. So because there is no indicator on the index 0, so means that this one start at n equals to 0, and this one also start at n equals to 0. Okay, so that's how we look for that value. So n, we will start at 0, and then we have a 1, 2, 3. So maybe we'll have up to 4. Okay. So if you don't really sure what will be the end of the n, so you just write any value first, because later you will see it. After you do the after you finish the answer, you will see what will be the end of the n. Xn is 1, 1, 1, 1. Hn is 0.5, 0.5. Then we can start do the multiplication. 0.5, 0.5, 0.5, 0.5, and then the other one is a 0.5, 0.5, 0.5. Okay, because we have only 2 samples on Hn, so you just need to multiply 2 times. And this is Yn, which is 0.5, 1, 1, 1, 0.5. Okay, so which is correct? Answer given by Omar and Connie is correct. So which is 0.5, 1, 1, 1, and 0.5. Okay, very straightforward. Convolution in discrete time system is 100 times easier than the continuous version. Okay, so let's see. So we have actually in this slide, we have several examples on convolution. Using maybe presented in a few perspectives. Okay, but if you are interested on looking into it to understand more, so you can look into the examples. Okay, so but worst case, if you are lazy enough, so you just do the shortcut method. Okay, and we have quiz 1, so you can do that also. You can do the it is you are given Hn, which is un minus 4, and then these are the xn. So you can try this one by one. So we have a 10 xn. Okay, so hopefully you can do this. and see and do the convolution. So anything, if you don't understand from this quiz one, you can ask me, right? Always you can ask me. Okay, so for IIR system, so which is the infinite impulse response, what we have done, convolution is for FIR. Okay, that's very specific. You can do convolution only if the system is FIR. Okay, we cannot do convolution for IIR system because IIR is we have an infinite impulse response. Length of the Hn is actually infinite. So when you need to do the summation, so you can imagine that if you do this even a shortcut method, what is your Hn? Your Hn is infinite. So you have infinite numbers of sequence of numbers. So that one is IIR. And just by looking at that, so we know that it is impossible to do this. It is impossible to do the convolution for IIR. Okay, so we have other solution for that, but we're not going to cover it this week. So in general, the difference equation of IIR system is shown below. Okay, so this is general equation for difference equation. So this is the summary. For IIR system, convolution will cause an endless computation as the length is infinite. Okay, so for below are the methods for obtaining the difference equation. So for FIR, we can use convolution. So convolution is for FIR alone. And we can use that transform also for FIR. But for IIR, we need to use a Z transform. We need to use Z transform. Actually, there's another way. We call it an initial value assumption. But we're not going to cover in this course. Okay, I'm not sure whether this is covered in a signal and system. So, but we're going to cover Z transform only. So now, what we have seen is only for FIR. Okay, for IIR, next week. That will be next week. Okay, just a quick quiz. Let's do just look at this and then just to identify whether this is IIR or FIR. So the first one, I'm giving you okay, the first one is very obvious. The first one is IIR because this is UN. You have samples from 0 up to infinity. The index from 0 up to index infinity. So this is IIR. Hn equals to delta n is very obvious also because delta n only has one sample. So this is FIR. So how about number 3? 1356 infinity. Is this FIR or IIR?
FIR.
Yes, true. This is FIR. Okay. So how many samples? Because if we said FIR, you need to answer how many samples.
5 samples.
Right. So 1, 2, 3, 4, 5. True. Correct. So that is 5 samples. Okay. It's just happened that the last sample is infinity, but this is not the index. This is not the index. Index for this one is 0, 1, 2, 3, 4. So this is 4. How about this one? Hn equals to alpha to the power of n.
FIR, 1 sample.
Yes. Okay, this is 1 sample. Okay, so there's because there is no, it's not. Okay, this one.
It's not index variable.
Yeah, there's not index. Okay, again. It's not index. Sorry, this is not FIR. This is actually IIR.
Oh.
Because whatever the n is, see, whatever the n is, so you have a value. Okay? It's not described. So because we can do this. So what is that? Hn equals to alpha n. We can do this one by one. H0 is alpha 0, okay, which is equals to 1. Do you have a value for H1? Yes, you have. It must be something. Do you have a value for H2? Yes, you have. So, but of course, you need to know what is the alpha. You need to know what is alpha. Even if you go straight until H infinity, you will have a value. You still have a value. Okay, it's like you are writing this, and actually it's not only starting from 0 up to infinity. So actually this is start from H minus infinity. Okay, so actually it starts from index minus infinity up to infinity. So obviously this is IIR. Okay, this is IIR. Okay, next, Hn equals to alpha, and so this is a little bit different, just a little bit different. Nothing, there's no un, this is where you have un. So means that it is the same with this one. It is the same, but you need to multiply with a step signal. Okay, that one is step signal 0, 1, 2. So what is the value before 0, before index 0 for step signal? 0. So it means that you're not going to have this value. So you will only have this one. Okay. So that's the difference between number 4 and 5. Number 4 and 5. And then let's see. Okay, last one. We look at another, just another one. Number 7. So what do you think? Un minus delta n minus 100. So is it FIR or IIR?
I would think it's an IIR.
So any of you think that this is FIR? Un minus delta n minus 100. Yes, actually this is IIR, because UN itself is IIR. And then you minus only one value, which is at delta n minus 100. So because you need to know how to imagine that. The best way is to sketch. This is UN up to infinity. 0, 1, 2. Everything is 1. And then you have another one, which is delta n minus 100. So maybe somewhere here is 100. So 0, and then you get into 100, infinity. Okay, so this is actually delta n minus 100. So what should you do is this signal, which is you have those, everything is a 1, minus a single sample here. So what we'll have is actually everything is still 1, except at this index 100, it becomes 0. Okay, the rest is still 1. So it means that you still have infinite numbers of samples. Okay, so actually we have another topic. I think we need to continue this next week because this Thursday, so actually this Thursday is a holiday, okay, Deepavali holiday, so we won't have a class. That's why actually this module is supposed to be a 3 hours class. Okay, but because I cannot cover this today, So we're going to cover these properties of an LTI system. Again, we're going to look at stability, causality, and then what is the impulse, and some linearity, linear properties, which is a commutative, associative, and distributive, which is actually quite simple things. Okay, but we're going to cover it on our next class. Okay, because there are some samples there. Since we have another 10 minutes, 10 minutes, I cannot finish the module. So I'm going to explain a bit on our assignment. Okay, we will use this 9 minutes for me to explain the assignment. Okay, looking at it at our planning here. Okay, so we have the plan here. So we have 14 weeks. Right? So we have 14 weeks, and we will start the assignment at week 7. So where we are? So we are at week 3. Now we are at week 3. So next week we will cover Z transform. Hopefully we can finish something on Z transform. And then week 5, we will do a test one. So then we have 1 week. And then after that, so we will have assignment. Okay, so this assignment is actually a group assignment. So it is a group assignment. This one is a group assignment. This one is a group assignment. But need to remember that most of the evaluation is individual. Okay, so it means that you cannot do nothing in your group. So you should do something. So if you don't do anything in your group, so you won't get marks. So maybe you'll get a very small marks because there is a group marks. This is a 2 star is actually group marks. Okay, 1 star is individual marks. So a group assignment assessed individually. And this one is a 2 star also, 5 marks. And to be specific, actually this 5 marks, these 5 marks, the 2 marks is actually individual. So the group marks is only 3. So this one is 3, this one is 3. The whole thing is 40 marks. So if you don't do anything, maybe your group is very good. So maximum you'll get only 6 over 40. Okay, so that is the group marks, 6 over 40. The rest will be individual marks. So you need to be very active. You need to be very active. So in the assignment. So what is the assignment? The assignment is the first one, we call it a jigsaw. Okay, so this is, if you look at here, so this is an expert group forum. So you need to get involved into a forum. This is a home group forum. This is another forum. And this is what we call a gallery walk. Gallery walk is, I will explain this later. But we will, there will be a this is a gallery. Gallery means every group will display your work. So every group will have an output. Okay, displayed to to all groups, and then all groups will comment on other groups' work. Okay, that's why we call it a gallery walk. So you will walk to one by one of the other groups' work and then comment. Okay, there will be a format here. So, but what is the content? The content is to learn MATLAB coding. Okay, MATLAB function related to DSP. So just learn on that one. Learn on that one first, and then the second phase. So that's why this is very important. This is very important. These 3 weeks, you need to learn the MATLAB function. This part, so this is where you're going to solve one filtering problems. There is no time to learn the MATLAB function anymore here. You should be able to learn the MATLAB function here. So this one, you just use that MATLAB function. Okay, so we have do the coding in 1 week. Okay, not much, 1 week, because you're already expert in these 3 weeks learning the coding. So this one just implementation, 1 week. And then you need to do some analysis on the results of the coding. And then you're going to present it. Okay, then you're going to present it. So even though it is week 7, it's supposed to be officially start at week 7. If you go to e-learning, this e-learning assignment section, this is assignment section, the question is already there. So you can look into that, into the question. The signal to be solved is already there. So you can already work on the signal. Okay, but the first phase, it doesn't need to solve the problem yet, because first phase is learning the MATLAB function. And these are, so this is the forum. So there's an expert group discussion. And this is some feedback. So hopefully you can read this feedback. Actually, this is from a previous semester. So what are actually have been done by the previous students. Okay, maybe you can get some insight from it. And this is another discussion, forum discussion. So let's look at this thing. And what should you do is share and discuss the individual note, because first week, if you look at here, so in this part, first thing is you need to read the question first. So in that question, you need to come up with a visual note. So we call it a visual note. It's like a mind map. Okay. So you'll be given some MATLAB function, and then you need to learn that MATLAB function and then create a mind map notes. So every one of you need to do that. And you can check actually from this e-learning, because I have this participant here. So everybody is already have a group. See, so there's an expert group A, home group 1. Okay, you are from section 3. So the most important is here, expert group A, home group 1. So this is for Hafiz. Okay, read the question, you will know. So if you are expert group A, which function that you should learn. Okay, if you are from expert group B, you should already know what to be learned. And then create a visual note from it. It needs to be a visual note. One page, visual notes. And then go to this group discussion, because it's supposed to start at week 7. But if you want to start now, you can, because the forum is already on. It's already open. Okay, so if you want to manage your time, you want to do it earlier, you can do it. So share and discuss the individual notes, because every one of you need to do that you have created within your expert group, this forum. Before the due date, improve your note based on the group discussions. First, just do the notes, and then do discussion to improve the notes. See, you need to work together to improve your own notes, And to score this discussion, 5 marks. Okay, 5 marks. So you need to get at least 3 rated posts. So who's going to rate? I'm going to rate the post. Each of the posts I'm going to rate. So to score a maximum marks. So if you get 3 rated posts, you'll get 5 marks. And these are the type of posts which will be rated. And these are the type of posts which is not going to be rated. Okay, read this thing carefully. Okay, so there's a lot of posting that you can do to get rated. It can be a question, it can be explanation on the question, it can be solution, it can be solution that have been put forward, but from a different perspective. Okay, it can be a reference, it can be improvement to other posted ideas. So maybe you are doing some visual notes, and you see someone from your friends, it looks like maybe you can improve something from that notes. So this is what it means, improve. You can summarize, okay? So just look at all whatever posts that's already posted by others, and then summarize it. Okay, summarize the ongoing discussion with comments on what has been covered and not covered. Okay, that's summarize, because sometimes we need a summary, because after maybe 20 posts, 30 posts, So it is good to have a summary. And then, of course, this is a critical comment to other posts by relating them to a new example of related theories. Okay, so look into this carefully. So, and need to be careful also. This is not rated. The first one is repeated idea. If you have a repeated idea, it will not be rated. All right. So, what is the point here? So you can start your assignment, even though it's supposed to start at week 7, because everything is ready. So you can start your assignment starting from now. Start reading the questions on what to do, and then you can start your assignment. At least you can start this assignment, the first phase. So on what is a jigsaw. But of course, gallery walk, you cannot start now. Gallery walk is supposed to be week 9, because this is a scheduled session. Okay, these two you can already start. Even you can already start this thing. Okay, after you have some solution, you keep it first until the time comes. You can submit. You can just submit it. Okay. So that's actually introduction to the assignment. So I will talk about the assignment from time to time because this is very important. So not much to submit. Many of the things is just a discussion. Okay. So what it means, you need to give ideas to the forum. You need to post. It's not good to do it late or at the end of the time. So let's say this is a week 8. So you have until let's say 18 December. So you do it on 18 December. So maybe you won't get a good post. Then your post might not be rated because it's not a good post. Okay, it needs time. So please plan your time to do the assignment. So everything is in the questions. Okay, any last question for today? Any last questions?
So how about the grouping?
The grouping? You can check from e-learning because here, as I mentioned, okay, actually everyone has a group already.
Yeah, sure.
Okay, you can check your own group from e-learning. So check within the e-learning. So you will see that. You will see that the group. Okay, any other questions? Okay, I think maybe that's all. So we still have some topics to be covered in this LTI system. So we will do it next week. Okay, so see you guys again next week. Assalamualaikum warahmatullahi wabarakatuh and a good afternoon.
Waalaikumsalam. Thank you, Doctor.